Chemical bonding. Chemical bonding is something that we use to explain how and why atoms attach to form more complicated things. Like, for example, they can attach to form molecules, or they can attach to form ionic bonds or ionic compounds, covalent bonds, or covalent compounds. We use the Lewis structures to represent chemical bonding, and Lewis structures are also known as electron dot structures because we use dots to represent the valence electrons. Remember, valence electrons are responsible for the reactivity, and also when a chemical bond is being formed by the sharing of electrons, the electrons that are being shared are the valence electrons. In a similar way, when the electrons are being transferred to form ionic bonds, the electrons that are going to be transferred are the valence electrons. So I'm going to start writing down Lewis symbols for elements. So I have on the left side metals, and then on the right side non-metals. So the first one is sodium, and sodium it's in group 1 in the periodic table, atomic number 11. So if we want to write down the Lewis symbol for sodium, we have to use dots to represent the valence electrons. Since sodium is in group 1 in the periodic table, that means that sodium has one valence electron. Now, when you have the symbol for your element, right, that symbol represents the electron configuration for the element with all of the core electrons. And then that valence electron that we're adding, right, is just the only valence electron that we have for sodium in this case, because you have just one valence electron for sodium. For sodium, the last thing that you have in your electron configuration is 3s1. Okay? So that valence electron for sodium is in an s orbital in the third energy level. So I'm going to represent my valence electron in the Lewis symbol for sodium, and we're going to use any of the four sides that you have around Na. So I'm going to make a line in any of the four sides. What I mean is on the top, left, right, or on the bottom. So I'm doing the lines just now, okay? When you have the actual Lewis symbol, there are no lines, just the dots for the representation of the valence electrons. So for sodium, you can choose any of the four sides where I place the line to put the electron, okay? And you can always do that for any symbol. Now on the right side, I have an example for a non-metal. Okay? The non-metal that I'm using is nitrogen. Nitrogen, it's in group 5 in the periodic table. If it's in group 5, it means that it has 5 valence electrons. Okay? So for nitrogen, we have to do something a little bit different from what we did for sodium, because for sodium, you have to worry about placing just one electron. So I'm going to start, you can start in any of the four sides around the symbol for nitrogen. Okay? So I'm going to start again on the right side, and we need to place five dots. So I'm going to put one dot, and then I'm going to move around. Okay, you're not placing all dots together. Remember, this is related to the electron configuration. For your electron configuration, in any orbital, you can put up to 2 electrons. Okay? The electrons are arranged in orbitals. When they have the same amount of energy, it's one electron at a time. And then if there are no empty orbitals available, we start pairing the electrons. So I'm doing one dot, then I'm moving here, second, 3, 4, and 5. Okay? So I go all the way around, placing one dot at a time. And then if you have to pair one of them, you put another one. You cannot have more than two dots together. Okay? The same way that you cannot have more than two electrons in each orbital. So I have 5 dots around nitrogen, representing each of the valence electrons for nitrogen. Let's do the same for potassium. Potassium is in group 1, the periodic table. If it's in group 1, it has one valence electron, which means that you need one dot. And I'm going to place it right there. Let's do a non-metal. Let's do oxygen now. Oxygen is in group 6 in the periodic table, which means that you have 6 valence electrons for oxygen. So I'm going to start placing my dots on the right side first. 1, 2, 3, 4, 5, and 6. Okay? So for oxygen, I have 2 pairs of electrons and then 2 lone electrons because it's just one electron by itself. One right here and another one right here. So for nitrogen, we have 3 lone electrons, okay? Single electrons, and then one pair of electrons, which is that one, that pair of electrons right there. Let's do one more. One metal and a non-metal. Magnesium, it's in group 2 in the periodic table. The electron configuration for magnesium ends in 3s2. Okay? It's in group 2, that's an s2. It's in period 3, that's the 3 that you have in front of the s. So 3s2. You have 2 valence electrons, it's in group 2, and those 2 valence electrons are these 2 electrons right here. So 2 electrons in an s orbital. So for magnesium, I'm going to place my 2 dots together because those 2 electrons are in the same orbital. Now for F it's in group 7 in the periodic table. So if it's in group 7, we need 7 valence electrons. So 7 dots around F, placing one dot at a time in each of the 4 sides around the symbol. And then we start pairing them. So 7 dots, I'm going to start here. 1, 2, 3, 4, 5, 6, and 7. So for F, we have 3 pairs of electrons and then just one single electron. Let's look now at the Lewis symbol for ions. I am listing here the symbol for some metallic elements and also for some non-metals. The symbols that we have are representing the elements. Okay? And now we're going to write down the Lewis symbol for the ions of those elements. So starting with sodium on the left, we have sodium in group 1 with one valence electron, and the Lewis symbol for sodium will have one dot showing that valence electron. The same thing for potassium, one dot showing that it has just one valence electron. Both of those elements are in group 1. Now, group 1 in the periodic table, elements in group 1 will form ions with a charge equal to +1, which means that they will be losing electrons. So your metals in group 1 will be losing one electron to have the same electron configuration as a noble gas. So sodium element 11, right, has 11 electrons, but the ion of sodium with a charge of +1 will have 10 electrons. The ion of sodium with 10 electrons has the same electron configuration as neon. Now, when we're writing down the symbol for the ion of sodium, we write down, and this is not the Lewis symbol, okay? This is just how we write down the symbol for the ion, right? You write down the symbol for the element, and then we use the charge. Sodium in group 1 has a charge of +1, so that's the ion of sodium right there. Now the Lewis symbol for sodium with a charge of +1 is exactly what I wrote right there. For sodium, you have just one dot representing the valence electron. When the element sodium loses one electron or gives away one electron, forming the ion of sodium with a charge of +1, it's giving away that valence electron. So if the dot in the Lewis symbol for sodium represents the valence electron for sodium, when the sodium, right, when it's being converted to the ion of sodium, it's giving away that valence electron, which means that for the Lewis symbol for the ion of sodium, we have no dots because sodium, to become sodium +1 or the ion of sodium, it will have to lose one electron, and that electron is the valence electron. Same thing will happen with potassium. The ion of potassium has a charge equal to +1. Potassium is in group 1, so the charge is +1. So potassium has 19 electrons. When it's losing one electron, it will go down to 18. If it's losing one electron to form the ion potassium +1, that electron that it's losing is the valence electron. So the Lewis symbol for ions, it has no dots because it's losing that valence electron. For magnesium, we have two valence electrons. Magnesium is in group 2 and it has two valence electrons. Now, in group 2, elements in group 2 will form ions with a charge equal to +2. So when magnesium is forming the ion of magnesium by giving away electrons, it will have a charge equal to +2, and the Lewis symbol will have no dots because magnesium, to form the ion of magnesium, will have to lose two electrons, and those two electrons are the valence electrons. Now looking at the non-metals, the metals will always form ions with positive charges. The metals always they are giving electrons away. The nonmetals are forming ions with negative charges. They're gaining electrons. So the symbol for nitrogen, the element, right? Nitrogen is in group 5. It has 5 valence electrons, so you have 5 dots around nitrogen. The elements in group 5 will form ions with a charge of -3. If the charge is -3, it means that those elements, to become the ion with a charge of -3, will have to gain 3 electrons. So the negative sign represents gaining, and then the number how many. positive sign represents losing, and then the number how many. So nitrogen has 5 valence electrons. The ion of nitrogen, since nitrogen is in group 5 and it has 5 valence electrons, it will form ions with a charge equal to -3. So the ion of nitrogen will look like this, nitrogen -3. Now the symbol, the Lewis symbol for the ion of nitrogen. Now I'm writing the Lewis symbol. The Lewis symbol for the ion of nitrogen. If nitrogen has a charge of -3, it means that it's gaining 3 electrons. So nitrogen is going from 5 to 8 electrons because it's gaining 3. If it has 8 electrons now, we need to write down 8 dots around nitrogen. So that will be the Lewis symbol for the ion of nitrogen with a charge of -3. It will have 8 valence electrons around. Now moving to oxygen. Oxygen is in group 6 in the periodic table. If it's in group 6, it will have 6 valence electrons. Now in group 6, the elements in group 6 will form ions with a charge equal to -2. So if the ion of oxygen has a charge of -2, it means that it's going from 6 electrons when it's neutral to 8 electrons because it's gaining 2. So we have to write down 8 dots around the symbol for oxygen when we're writing the Lewis symbol for the ion of oxygen. So we have 8 dots around oxygen again. Now let's look at the last one here for the non-metals. We have F. Okay? So F is in group 7, fluorine in group 7 in the periodic table. You have 7 valence electrons. Any element in group 7 in the periodic table will form ions with a charge of -1. So if you have 7 electrons in the neutral atom, when you have the ion with a charge of -1, you will have 8 electrons again. So the symbol for F, right, with a charge of -1, if it has a charge of -1, that means that it's gaining 1 electron and it's going from 7 to 8 electrons. So we can see a trend for the Lewis symbol for ions. If you check the Lewis symbol for the metals here, Lewis symbol for the metals, you have the ionic symbol showing you the symbol for the element, the charge that you have, and no dots around because the metals are losing those electrons. Okay? So no dots around the symbol, Lewis symbol for the metallic ions. And then when we move to the right side where we have the non-metals, you can see that for my 3 non-metals here, all of them will have 8 dots around the symbol. So non-metals are gaining electrons to have 8 electrons around. So that's the Lewis symbol for the ions for your non-metals, the ones that are circled in blue. All of them are gaining electrons and all of them are going to 8 electrons around. So this here is not just for the three examples that we have. That will apply to every, it's something that we use in general, okay? So for every metal in the periodic table, you will have the ionic symbol with no dots around as the Lewis symbol. For the non-metals, you will have the ionic symbol with 8 dots around. Okay? Now, when we can use that information to write down the Lewis symbol for ionic compounds, you just have to write down the Lewis symbol for the metal of the elements that you have listed there. So I'm going to do the first one. You have Na3N, that's sodium nitride. Okay, so the Lewis symbol for the ion of sodium is the symbol of the element with the charge of the ion. It's in group 1, so that charge is +1. Now, the Lewis symbol for the nitrogen. Nitrogen -3, it's going from 5 electrons to 8 electrons. Right? If you have an ionic compound, it's because the metal is giving electrons to the non-metals to form those ionic bonds. So you have the ion of sodium with a charge of +1 because sodium is losing electrons. And then you have the ion of nitrogen, which is the nitride, right, with a charge of -3, and those ions are gaining electrons. Each one is gaining 3 electrons. And when it gains 3 electrons, it goes from 5 to 8 electrons. So you see, when I'm writing the Lewis symbol for the ionic compounds, I'm doing exactly the same thing that we did here for the elements. I'm writing down the symbol for the metal as it is. Na, it's in group 1 with a charge of +1. And then the symbol for the non-metal as it is in the periodic table, it's N, a charge of -3 because it's in group 5. If you have a charge of -3, then your number of electrons will go to 8. So I have 8 dots around. So we're almost done with the Lewis symbol for that compound sodium nitride. Something else that we do to represent the symbol for the compounds is that we use brackets to put them like that. You can, depending on the reference that you use, you can see the metal and the non-metal both in brackets. Usually you have the metal without the brackets and then the non-metal with the brackets. So you have everything inside of the brackets. And then there's something else that we need to look at. When I was writing down the symbols for the ions, I was not taking in consideration this number here. You see, I just wrote Na with the charge of +1 because that's the charge that you have for the ion of sodium, and nitrogen with the charge of -3 because that's the charge that you have for the ion of nitrogen. 8 dots around because nitrogen is gaining 3 electrons to go from 5 to 8. But that 3, which is a subscript, is telling you how many ions of sodium you have in this specific compound. In this specific compound, you have 3 ions of sodium, 1 ion of nitrogen. Okay? So the subscript here, it's part of your Lewis symbol. Now I'm going to explain to you what's happening here with the electrons very quickly. The element sodium has 1 valence electron, and when you're forming the compound, when the compound sodium nitride is being formed, you have 3 ions of sodium right there. So I'm going to write down the same thing 3 times. The ion of nitrogen has a charge of -3, right? But nitrogen, as it is in the periodic table, you have 5 valence electrons. Now, when the compound, ionic compound, is being formed, you have sodium plus 1. So sodium is losing, each sodium here is losing 1 electron. Your nitrogen needs to form an ion with a charge of -3. So it has to gain 3 electrons. So how this works is that your sodium will be transferring the ions to the nitrogen to form the nitride. You see how nitrogen needs 3 electrons to go from 5 all the way to 8. Sodium, one atom of sodium can give away 1 electron. So if you have just one atom of sodium, you will have nitrogen now with 6 electrons instead of 8. So for that nitrogen to go from 5 to 8, it needs 3 electrons. Since each sodium can give away only 1, you need 3 sodium ions. That's why the formula for sodium nitride is Na3N. 3 ions of sodium are required for you to have enough electrons for that nitrogen to go from 5 to 8 having a charge of -3. So I'm going to write down the Lewis symbol of the second one very quickly. You have potassium. Potassium is in group 1, so the ion of potassium has a charge of +1. You have oxygen in group 6 with a charge of -2. And if it has a charge of -2, it means that it's going from 6 to 8 electrons. Oxygen, the element neutral in the periodic table in group 6, will have 6 valence electrons. The ion of oxygen with a charge of -2 is gaining 2 electrons, so it will go from 6 to 8 electrons. So I'm going to put the dots around because it's always 8 for the nonmetals. And the electrons, they go in pairs. So I have my oxygen with 8 electrons. Let's put that in a bracket. And now again, the subscript, we have to use the subscript because for every oxygen that you have 2 potassium in that ionic compound. And then the third one, again, magnesium fluoride. Magnesium, it's in group 2. It's forming ions with a charge of +2. No dots around the metal because they're losing the valence electrons, so you don't have any dots for the metal ions. You see, I don't have any dots around sodium, potassium, or magnesium. And now for the non-metal, F will have a charge of -1, group 7 -1. It goes from 7 electrons to 8 electrons. We need the bracket and we cannot forget about the subscript. We have 1 ion of magnesium in that formula and we have 2 ions of fluoride in the formula. So now you have 2 examples here for you to work on: aluminum oxide and calcium phosphide.